Good afternoon, sir. Good afternoon, classmates. We will be discussing the type of fuel, which is the liquid fuel. I'm Ayeza Camille A. Urquiza, and let's start. Liquid fuel. Liquid fuels are those that are commonly used for internal combustion engine and are typically needs to be vaporized before combusted. It is also combustible or energy generating molecules that can be harnessed to create mechanical energy to typically kinetic energy. Instead of the fluid itself, liquid fuels are flammable in their fumes. The common liquid fuels are derived primarily from crude oil, which exists in liquid form in underground reservoir in the process, like in the spaces within sedimentary rocks. It is also made up of hydrocarbons, hydrogen, and carbon atoms. And now, we proceed to the video that we prepared the refining process of petroleum. Next po sa video. Sa video po.
Hello po, naririnig po.
Petroleum is obtained by drilling holes or oil wells into the Earth's crust. When a well is drilled through the petroleum-bearing rocks, usually natural gas comes out first with a great pressure. This is followed by crude oil, which comes out due to the gas pressure. Petroleum is separated into its constituents by the process of fractional distillation. Fractional distillation of petroleum is done by using a tall fractionating column or fractionating tower as shown here. Crude petroleum is heated to a temperature of about 400 degrees Celsius in a furnace, and the vapors thus formed are passed into a tall fractionating column from an inlet at its base. As the mixture of hot vapors rise in the column, it starts getting cooled gradually. Due to this, the vapors of the higher boiling fractions of petroleum condense first in the lower part of the tower, but the vapors of the low boiling fractions rise up into the tar and condense later. In this way, the fraction of petroleum having the highest boiling range is collected in the lowest part of the fractionating tower. The fraction having the lowest boiling range is collected in the topmost part of the tower. The various fractions that are obtained by distillation of crude petroleum are tabulated here.
From the outside, an oil refinery looks like a small city. A city composed of pipes, tanks, and towers. But if you went inside, you might be surprised to find one of the most technologically advanced industries in the United States. Here, engineers and scientists have figured out how to turn raw crude oil into the valuable fuels, lubricants, and components we need to make millions of products. Refining begins with a process called distilling. After oil is superheated, it becomes vapor. The vapor is fed into the distillation unit. As it rises and cools, the vapor turns back into a liquid. Using stacks of trays, the liquid is easily collected and separated by weight. The lighter and medium weight liquids require less processing before they're ready to be used in cars and trucks. The heavier liquids need more processing to become useful. A process called cracking is used to maximize the usefulness of heavy oil. Heavy oil has long strings of carbon and hydrogen molecules. Using a catalyst, these molecules can be broken into smaller chains, transforming the heavy oil into lighter, more valuable fluids. Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but the structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable gasoline-like molecule. Blending is a process of mixing different refinery products to make finished petroleum fuels. Gasoline, for example, is blended to achieve octane standards, creating the grades of gasoline you see at the pump: regular, mid-grade, and premium, that are necessary to meet the needs of specific engine types. Treating is a process used to produce cleaner gasoline, which helps protect both the environment and our health. Gasoline molecules contain impurities like sulfur that can be removed. When the molecules are heated and come in contact with a special catalyst, a chemical reaction occurs that strips the sulfur away. These sulfur compounds are used as fertilizers and in pharmaceuticals. Nothing goes to waste in a refinery. In fact, by expanding existing refineries and improving their efficiency, we've increased production of refined products by more than 40% since the 1970s. So the next time you drive by a refinery, think about the scientists and engineers who are helping to efficiently transform raw crude oil into the fuels and products we use every day. Their innovative work helps keep prices low for the many things we use in our daily lives. And think about how refining, like other types of manufacturing, supports entire communities. Put it all together, and you'll see how refineries keep America moving.
So yun po yung video presentation po for the refining process po. So dito po simpler view po of how the refining process works po. Which is where magsisimula po tayo dito sa crude oil from down up to pataas po. So with the use po of evaporation po and higher and temperature po, umaakyat po yung iba't ibang gases po na may po-produce po sa pag-refine process po. So next po is isa-isahin po natin yung refining process of petroleum po. So number one is cracking. So cracking consists of breaking down large and complex hydrocarbon molecule into simpler compounds, and it is by means of heat and pressure, and it is one of the most important processes po sa refining of petroleum po. This type of process also yields light oils, like for example gasoline and diesel, although po middle range oil na po yan, pero counted pa rin po yun. And since bine-breakdown po niya yung mga hydrocarbons into smaller ones, mas useful po ito sa fuel kesa po dun sa mga malalaking hydrocarbons po. So this also produce alkenes, which are used as feedstock for the petrochemical industry. So there are two types of cracking. The first one is thermal cracking. So thermal cracking, ginagawa niya po is yung mga hydrocarbons po, ito-turn niya po into gas, then yun po ay imimix po sa steam at 850 degrees Celsius po. And then, yun nga po, mag-split po or yung mga malalaking hydrocarbons po na to magsi-split into smaller and shorter ones, and mag-yield po ng alkenes po, which are used to make polymers po. Then next one po is catalytic cracking. So by the name itself, it uses catalyst po. So yung mga catalyst po na yun, specifically po na ginagamit po is aluminum oxide po. So ang ginagawa po dito, yung mga hydrocarbons po, as gas passes over, hinahalo po yung hydrocarbons habang yung mga gases po nagpapas sa isang mainit and sa powdered aluminum oxide na catalyst po. And it is heated at 550 degrees Celsius po. Mostly, yung mga nagagawa po dito, mga short-chain alkanes po. So, yung mga alkanes po is useful rin po as panggawa po ng fuels po. So, next one po is hydrogenation. So, this is the process of adding hydrogen atoms to the hydrocarbons at high temperature. So, yun nga po, ginagamit po siya, ginagamitan po siya ng high temperature and pressure which moistens the oil using hydrogen po. Yung hinahaluan po siya ng hydrogen. So, ito rin po, in the presence of catalyst rin po, ginagamitan rin po siya ng catalyst. Typically po, mga nickel compounds po. And isa pa pong process rin po nito is adding hydrogen to unsaturated hydrocarbons for stabilization po ng petroleum products and pagre-reduce po ng or aromatic reduction. So, next po is polymerization. So, polymerization is a process of converting olefins. Yung mga olefins po is yung mga ethylene, propylene, butylene, mga unstable products of cracking po. At gagawin po siyang into heavier stable compounds or heavier and higher octane number that may be used as pang blend po sa gasoline stock. Ito po ay ma-accomplish po by thermally or in the presence rin po of catalyst at lower temperature. So, same po sa hydrogen po tsaka sa catalytic cracking rin po, gumagamit sila ng catalyst po. So, next po natin is alkylation po. So, it is a chemical process na nagko-combine po ng olefin and isoparaffin to produce a branch chain isoparaffin. So, in the presence rin po ng catalyst. So, kumbaga po, it's a chemical process in which light and gaseous hydrocarbons, so yun po yung mga yun po yung isa po doon is yung olefin, yung isa po doon is yung isoparaffin. To produce higher octane and high octane components of gasoline po. So, yung ginagawa po nito, from the name itself, alkylation, gumagawa po ito produce po sila ng alkylates. So, yung mga alkylates po, it is a high in octane but has low volatility and can be added to motor gasoline and aviation gasoline to increase octane while meeting yung mga stringent volatility specifications po na ginagamit po sa mga gasolina po na yun. So, there are two processes po of this type of alkylation po sa pagbibigay sa paghalo po ng catalyst po niya. So isa po dun is using concentrated hydrofluoric acid as catalyst po, and yung isa naman po is using concentrated sulfuric acid as catalyst po. So next po is isomerization.
Rinig po ba? Isomerization. From the word itself, isomer, there is no change change of number of carbon and hydrogen atoms. It is a process of converting olefins, the unstable products of cracking, into heavier stable compounds. It it only rearrange into more useful isomer. It converts small hydrocarbon to larger ones by using a catalyst. Next, next. Cyclicization joins together the ends of a straight chain molecule to form a ring compound of the naphthalene family. Next, aromatization joins together the ends of a straight chain molecule to form a ring compound of the aromatic family. The main difference of these two is naphthalene have single bonds between carbon atoms, whereas aromatics have both single and double bonds. Branch and rings hydrocarbons have higher octane rating, therefore it combusts more smoothly than straight ones due to its surface area. Straight chain hydrocarbons tends to explode reformation. Reformation. A type of cracking process which is used to convert the low at anti-knock quality stocks into gasoline fire octane rating. It does not increase the total gasoline volume po in um in order to understand the formation, we must know what is octane number and its relation to antenna quality. Lower octane gas burns quicker than higher octane, and therefore it requires less energy to ignite. For example, in a piston cylinder, in compression stage, yung air and fuel mixture is compressed. Pag lower octane gas po, nagpe-pre-ignite siya before hitting the spark plug. Therefore, it produces smaller compression ratio. Therefore, lower engine efficiency. Next, please. Next po. Is a process of obtaining a product of desired quality by mixing certain products in some suitable proportion. By adding additives like ethanol, methanol, we get different grades of fuel like we see in a gas station. Um, low octane, regular as low as the lowest octane number and the premium ones as highest octane rating.
For basic information, the basic functions of the refining can be broken down into three categories of chemical process: the distillation, cracking, and lastly, reforming. In distillation, separation of materials based on differences in their volatility; cracking, which involves breaking up heavy molecules into lighter and more valuable hydrocarbons; reforming, which involves changing the hydrocarbons' chemical nature to produce desired physical qualities and also to increase the market value of those chemicals. To turn crude oil into useful products like LPG, gasoline, or petrol, kerosene, jet fuel, diesel oil, and fuel oils; petroleum refining is a must. There are numerous contaminants in crude oil that must be removed, and it is also to ensure that we get pure compounds. At the given table, it is the product of petroleum refining process. And now, we proceed to types to be tackled by Mr. Ipio. Based po sa sa refining process po, ayan po yung mga na produce po sa pag-process po ng petroleum na nakukuha po sa crude oil.
So, naka-base rin po siya sa ano niya po. Sa kung saan po yung accurate po na heat na kailangan po para ma-refine po from the crude oil to magawa po to hanggang magawa po dito sa isa-isa po na to na fuel gas, propane, butane, light naphtha, and so on and so forth po. Mga ano lang po, ah, mga natira, mga tawag dito. Yung mga kung ga, kung gaano po sila karami po na produce po from sa crude oil po. Yes po. Ay, sorry po sir, napindot lang. Yan po, meron na po ba? Ay, yung tapos na po yung sa refining process po. Itutuloy na po sa ano po sa types na po ba? Tapos na po sir dun sa refining process po. Itutuloy na po sa types. Hello po.
Hello po, sir. Tapos na po yung sa sa refining process, itutuloy na po yung sa types po. Mr. Ipio.
Audible po. Audible po ba? Apo, sir. So, and types of liquid fuel, number one, gasoline. It is a blend of alkanes, cycloalkenes and aromatics which vary slightly at different references. It is also generally known as isooctane. Octane is a good solvent. It is fuel's ability to withstand compression uh, without detonating. Uh, high octane high octane rating during compression of spark ignited combustion engine, mas nape-prevent po nun yung detonating po. Tapos para po makapag produce po ng gasoline, it is achieved by distillation of crude oil. ah at dito po ang tatanggalin lang po yung petroleum. Tapos it is most common in spark ignited combustion engine. Dahil ang boiling point niya po ay from temperature na 35 degrees Celsius to 200 degrees Celsius. Next po. And diesel. It is a mixture of C10 to C15 hydrocarbons with a higher boiling point range than gasoline. There are different grades of diesel fuel with varying application. The average chemical formula is C12H24. Diesel, it is most common in diesel engines. Diesel engine po, yung fuel ignition without a spark but a result of compression of air and then the injection of the fuel. Ang boiling point naman po ng diesel ay 250 degrees to 350. Next po. Fuel oil. Heating covers a wide range of petroleum products and are divided into 6 different grades. Fuel oil po ay mainly residues from crude oil distillation. Tapos, used primarily for steam boilers in power plants. Yung 6 different grades niya po, nagdedepende po yun kung paano po siya gagamitin. Like for example po yung number 1, outdoor stove and portable outdoor heaters. Yung po yung for example po yung mga vaporizing pot types. Tapos yung number 2 po yung sa mga commercial industrial burner o yung mga automizing type po. Tapos number 3 po yung blend of distillate and residual fuel stock or yung sa commercial burners naman po. Tapos yung number 4 po yung po yung yung sa more viscous po than po dun sa mga naunang example po. Tapos yung fuel oil po, tinatawag din po siya minsan as furnace oil. Next po. Naphtha. It is a mixture of volatile liquid hydrocarbons that are used as feedstock for other products including gasoline. Ito naman po ang tinatawag po na white gas. Flammable liquid hydrocarbon mixture produced from natural gas condensate, petroleum distillate, and distillation of coal, tar, and also be crude oil or refined kerosene. Mas po siya, most common po siya sa mga lanterns and torches.
So dito po makikita niyo po yung typical properties po sa fuel oil po. So sa fuel oil po na dinidifferentiate po dito is yung kerosene and distillate, very light residual and mga residual na mga fuel oils po. So next na po.
Sa specific gravity po, ano po, si Paul po. Wait lang po, i-discuss po ni Paul Tambago.
Bomb po yata. Bomb po. Yes po.
Di ka ata hunig, Paul.
Hello po, hello po. Hello po.
Audible na.
Yeah, sensya po. So, sa property naman po ng liquid fuel ay yung specific gravity. Yung specific gravity ay the density of the fuel divided by the density of the water at the same temperature. So, for liquid fuels, the standard is to use the Boehme scale. Yun po. Yung pronunciation po ay Boehme. So, ang formula po ay degree Boehme is equal to 140 over the specific gravity at 15.6 degrees Celsius minus 130. So, may another scale use po is the American Petroleum Institute or the degree API gravity, and it is measured at the reference temperature of 15.6 degrees Celsius. Ang formula naman po ay degree API is equal to 141.5 over the specific gravity at 15.6 degrees Celsius minus 131.5. Yun po. Next slide po tayo. Tapos po, if the specific gravity given is for another temperature sa isang problem, we can use correction, what we call correction factor. So for the SI unit, we can use CF is equal to 1 minus 0.00072 multiplied to the temperature minus 15.6 degrees Celsius. For the English unit, we can use CF is equal to 1 minus 0.0004 multiplied to the given temperature minus 60 degree Fahrenheit. Then the specific gravity at the desired temperature is equal to the specific gravity subscript ay yung given temperature is equal to the specific gravity at 15.6 degrees Celsius multiplied to the correction factor. So next po ay try naman po natin ng example 1. The problem is calculate the minimum volume of the tank of 28 degree API fuel having a fuel consumption of 1 kilogram per second if the temperature is 20 degrees Celsius. So, analyze natin, ang given sa problem ay ang degree API ay equal sa 28 at ang given mass naman ay 1 kg per second. Then the given temperature is 20 degrees Celsius. Ang hinahanap sa problem ay yung volume of the tank per day. So, gagamitin nating formula ay yung formula ng density, which is mass over volume. Since ang hinahanap natin ay yung volume ng tank, we can see that volume is equal to mass over the density of the fuel at 20 degrees Celsius. Next slide po. Next slide po natin. Yan po. Assuming yung the tank has the capacity of use of fuel. So, i-convert po muna natin yung given mass, which is 1 kilogram per second. So, to convert it, we need to multiply it to 3,600 second per hour. So, multiply to 24 hour per day. Makukuha natin yung given ng mass na 86,400 kilogram per day. Yun. For the density naman, which is at 20 degrees Celsius, ang formula ng specific gravity kanina, di ba, ay density ng fuel over the density ng water. So makukuha natin yung formula na to, which is yung density ng fuel at 20 degrees Celsius ay magiging equal sa specific gravity na at 20 degrees Celsius multiply sa density ng water. The specific gravity at 20 degrees Celsius naman ay yung kaninang formula, which is yung specific gravity at the given temperature multiply sa specific gravity at 15.6 degrees Celsius multiply sa correction factor. At ang makukuha ang iyan natin na correction factor ay yung SI unit. So, ganun yung kakalabasan nun. Yung specific gravity at given temperature is equal to specific gravity at 15.6 degrees Celsius multiply to 1 minus 0.00072 multiply to temperature minus 15.6 degrees Celsius. Next slide po. Ito na po. Una natin kunin ay yung specific gravity at 15.6 degrees Celsius. Since may formula tayo ng degree API at may given na degree API, so degree API is equal to 141.5 divided by specific gravity at 15.6 degrees Celsius minus 131.5. I-input lang po natin yung value ng given degree API, which is 28. Makukuha na natin yung value ng specific gravity at 15.6 degrees Celsius, which is 0.8871. So para makuha naman natin na ang specific gravity at 20 degrees Celsius, substitute lang natin ang specific gravity at 15.6 degrees Celsius, then makuha natin ay 0.8871 multiply to 1 minus 0.00072 multiply to 20 degrees Celsius minus 15 degrees Celsius. Ang makuha nating specific gravity at 20 degrees Celsius ay equal sa 0.8843. Next slide po. Kaya po kinuha siya sa 15.6 kasi po ang standard formula po natin ay laging sa 15.6 tapos po ang tinatanong po sa problem ay yung specific gravity at 20 degrees Celsius para po makuha yung volume ng temperature po na yun. base lang po sa module, yung standard standard temperature ay yung 15.6 degrees Celsius o kaya po 60 degrees Fahrenheit. 60 degrees Fahrenheit po. Apo. Tapos next, yes po, pwede po siyang kunin pagka ganun, yung formula po may gagamitan po siya ng correction factor pagka yung given temperature ay hindi po 15.6 degrees Celsius. So for the density naman, kunin natin yung density ng fuel at 20 degrees Celsius, which is equal sa yung 0.8843, yung nakasulat kanina na formula, yung density ng fuel ay equal sa specific gravity multiply sa density ng water. Kaya naging 0.8843, yung nakuha natin kanina, multiply sa density ng water, which is 1,000 kg per cubic meter. So, ang makukuha nating density ng fuel at 20 degrees Celsius ay 884.3 kg per cubic meter. And ngayon, ang final solution natin na hinahanap ay yung volume per day. Ang nakuha nating formula ay volume is equal sa mass over the density of the fuel. So, input lang natin yun, which is yung mass, 86,400 kg per day, all over the density, which is 884.3 kg per cubic meter. So, makukuha natin volume ay 97.70 cubic meter per day ng tank. Yun po.
Good afternoon po. Ako po si Alexander Ching. Tas i-discuss ko naman po yung second property, which is heating value. Yung heating value po, ito po yung amount of heat o energy liberated sa pagsunog po ng fuel. Tas yung ASTM D48687 po. Ito po yung test method na nagko-cover sa estimation ng gross at net heat ng combustion in SI units. Bali may dalawa po tayong formula na pwedeng gamitin. Yung ASME formula for petroleum products tsaka yung Bureau of Standards formula. Yung ASME po, nag-stands for American Society of Mechanical Engineers. Tas yung formula po nila is heating value equals 41,130 plus 139.6 times degrees API. Tas yung sagot po, in kilojoule per kilogram. Tas sa Bureau of Standards formula po, yung heating value is equals to 51,716 minus 8,793.8 times specific gravity at 15.6 degrees Celsius squared in kilojoule per kilogram din po. Saan po, sir? Bali sa liquid, na po ata to, sa liquid fuel po. Solid po. Opo. Yes po.
Sir.
Kasi ito po yung sample problem po natin. Calculate the heating value of fuel having 28 degrees API if the temperature is 20 degrees Celsius. Use the ASME formula and Bureau of Standards formula and compare the answer. Yung given po natin is degrees API equals to 28 degrees, tas yung temperature is equals to 20 degrees Celsius. Yung required po natin is heating value at ang gagamitin po natin ay Bureau of Standards formula tsaka ASME formula po. Next po. Bale, isa-substitute lang po natin siya. Bale, ito pong una, using ASME formula po dapat to. Bale, heating value is equals to 41,130 plus 139.6 times 28. Tapos ito po magiging sagot. Heating value is equals to 45,038.8 kilojoule per kilogram. Tapos using Bureau of Standards formula naman po, heating value is equals to 51,716 minus 8,793.8 times 0.8871 squared. Tapos magiging, bale, eto po, nakuha po to dun sa mga previous slides po. Bale, sa slides po ni, sa banda po kay Paul, nakuha po. Tapos yung sagot po, heating value is equals to 44,795.75 kilojoule per kilogram. May difference po sila na 240 kilojoule per kilogram. Next po.
Hello po sir, narinig po yung ano, yung recording po. Okay po. Yes po, wala. Yeah, okay po. Yung dito po sa part na po na to, kasi po yung yung magre-report po may emergency daw po eh. Ayan po ba, narinig na po? Ah, mm, ah, parang hindi ko po makita eh. Ayan po, narinig na po. Wala po. Hmm. Ayan po ba?
This is the amount of heat that must be supplied to obtain a certain air mixture. 3 parts. First one is heat to raise the air temperature to the equilibrium temperature. Second, heat to raise the fuel temperature to the same temperature. And last, the latent heat of evaporation of the required part of the fuel. So the liquid fuel can be burned in pools or sprays. The burning process starts with the vaporization of the liquid fuel. There is required amount of heat to raise the air and fuel temperature up to the equilibrium temperature. Lastly, the latent heat, also called the heat of vaporization, it is the amount of energy necessary to change a liquid to a vapor at constant temperature and pressure. Viscosity. It is a measurement of a liquid's resistance to flow, and it indicates the ease at which the fuel can be pumped and atomized. For example, the fuel viscosity control is a technique to control viscosity and temperature of fuel oil for efficient combustion in diesel engines of motor vessels and generator of oil-fired power plants. It strongly depends on the temperature. The higher the temperature, the lower the viscosity. Viscosity. Volatility is measured by rate vapor pressure, which is the equilibrium pressure exerted by vapor pressure over liquid at 37.80 C. It describes how easily a substance will vaporize that turns into gas or vapor. One example is alcohol or gasoline. It usually applies on liquids. Flash point. It is an indication of the maximum temperature at which liquid fuel can be stored and handled without serious fire hazard. The flash point is a general indication of the flammability or combustibility of a liquid. One example is that the flash point of the liquid hydrocarbon, it is the temperature to which it must be heated to emit sufficient flammable vapor to flash when brought into contact with the flame.
So next po.
Good afternoon po, sir. Rinig po ba? So, ako po si Warly De Vera and I'm discussing more about the properties of liquid fuel. Pour point. It is the lowest temperature at which fuel oil can be stored and still be capable of flowing under very low forces. So, kapag mas bumaba pa yung temperature less than the pour point of a petroleum product, it cannot be stored or transferred through a pipeline. The pour point of crude oils relates to their paraffin or alkane content. The higher the paraffin content, the higher the pour point. Next po. Next po. Next is cloud point. It is the lowest temperature at which fuel oil will start to form crystals. So these crystals or solidified waxes thickens the oil and clogs fuel filters and injectors in engines. So kapag bumara po yung mga namuong crystal sa fuel filters and fuel injectors natin sa engine is pwede po siyang maging sanhi ng mga problema. Next po. Next is the auto-ignition temperature. It is the lowest temperature required to initiate self-sustained combustion in a standard container in atmospheric air in the absence of spark or flame. At the auto-ignition temperature, the temperature alone provides sufficient energy to induce combustion. This temperature is required to supply the activation energy needed for combustion. The temperature at which a chemical will ignite decreases as the pressure increases or oxygen concentration increases. It is usually applied to a combustible fuel mixture. So due to the various factors affecting the determination of the auto-ignition temperature, octane and cetane number are used. So una po is yung octane number. In simple terms, it is the measure of the performance of a fuel. So tinatawag din po itong anti-knock rate of fuel. So when fuel is used in an engine, the engine will generate a knocking effect. In other words, the fuel can cause the engine to undergo knocking when burned. So the greater the octane number, the greater the anti-knocking property of the gasoline. So yung knocking po na tinatawag natin dito is yung hammer-like sound na naririnig natin sa makina kapag mayroong biglaang pagtaas ng pressure sa combustion cylinder. Next po is yung cetane number. Yung cetane number po is makikita natin to sa mga diesel engine. It is the measure of the delay of the ignition of a fuel. So ang combustion po ng isang diesel engine ay nakarelay po sa fuel injector o yung pag-i-inject ng fuel directly sa combustion chamber. So sa compression stroke po nito kung saan hot highly compressed na yung air is instead na spark is doon po i-inject yung fuel. So it is the highly dynamic compressed air that is sufficient to initiate combustion when the fuel is sprayed to the cylinder. So inject po ng fuel, doon po magsisimula yung combustion. Pero in reality po, hindi po kagad nagsisimula yung combustion pag inject ng fuel. Meron pong maliit na time delay, millisecond delay po at ito po yung sinusukat o tinatawag po nating cetane number. So the ignition lag should be small to avoid combustion knock. The recommended minimum cetane number are 25 to 35 for low speed, 35 to 45 for medium speed, and 45 to 50 for high speed engines. Yun lang po.
I hope you learned something about our topic. Thank you for listening. That's all po. Basta po, sir. Sir, sir, tapos na po. Yes po. Tapos na po. Tapos na po lahat. Thank you po. Sige po. Thank you.
Thank you po, sir.
Thank you po.
Thank you po.
Thank you po,
Thank you po,
sir.
sir.
Ingat
Ingat
din
po.
po.
Thank you po, sir.